So this is lesson 2-8, and I'm going to give you what it's called, and then we'll talk about where it's a term that I have never used. It's called literal equations. Now I'm going to give you what we used to call it, transforming equations. Yep, like a transformer. So today's date is the 7th. Okay. So I'm going to give you the definition of a literal equation, and then I'll give you an example. I'm going to give you 3 examples, and the literal equation will be the last example I give. But I am going to talk about this notion of a transforming an equation. So let's go with that literal equation. And I don't know why they use this terminology, to be honest with you. This is new in Common Core. It may have an implication in higher math. I'm, again, I've been teaching algebra and geometry for the last 10 years, so I don't know what's going on in the other classes. So this is actually the name of something you are familiar with. I'll throw some out at you and see if you can figure out the common word for what I'm describing. A equals LW. P equals 2L plus 2W. V equals pi. Hi. Oh, okay. On my desk would be great. I heard somebody. Formulas. Okay, and that is the term that we're used to. I'm used to. I've used for years. Is the word formula. Okay, so literal equation is a formula. Okay, we have a whole bunch of variables, but those variables tend to have values that we're going to substitute in. Okay, so another way of saying it, it's an equation with several variables. So notice the word equation, meaning there's an equal sign. So we're going to deal with any kind of equation that has an equal sign, that has more than one variable, and we're going to go ahead and play around with it. So we're going to use the same techniques that we used before for solving an equation. They're the same exact order on my equation card that I'm going to use with these sorts of things. Now, why do we call it transforming? How many of you have ever had a transformer toy? Okay, so what's awesome about a transformer is the parts don't come off, right? You just take your object. Perry, tell me, what was your transformer? What were the 2 things?
I had Optimus Prime.
Okay.
Come on, you gotta have Bumblebee, bro.
Okay.
No, I had Megatron.
Okay, so Megatron is some sort of monster. What did he become when he transformed? A plane?
He goes into like a tank, a plane. He goes into more.
Okay.
Yeah.
Oh, wow. So he could become some sort of means of transportation, or he could be like this evil annihilator, right? Okay. I don't really know much about these guys. Sorry. I'm not a game person, like that kind of game. So basically what happened is you would just take him, twist him around, and put things down, bend down, put behind, whatever, but the pieces didn't come off. So you basically have the same exact structure, you just rearrange how it looks. And that's exactly what we're going to do with these equations. We're going to take the structure and we're going to rearrange how it looks using our properties of equality that allow us to take care of things. Oh, one thing I did notice is that some people were trying to get rid of coefficients first, which you cannot do. You cannot do multiplication or division first when you're solving an equation. You're either going to add or subtract to get the variables together on one side. You're going to add or subtract to get the constants together on the other side. The last thing you're going to do is multiplication or division. There is one exception to this rule, is if you have a fraction to begin with. You can get rid of the fraction to begin with by multiplying both sides. But what I saw people do is they would take 2 terms and they would do math with them alone. And there would be 3 other terms in that equation that Nothing happened to. That's not equality. That's inequality. And we all fight inequality. Okay? So let's look at an equation. You're going to, let's just add here, solve for a particular variable using math properties. So I'm just going to give a quick rundown. So we're going to add or subtract. This is the general. Most of the problems follow this. You're going to add or subtract to get variables. And I'm just going to say on the left, bless you. Though you know that you can take them to the right. Nico, we're taking notes, bud. You can add or subtract to get constant. Oh, to get. On the right. So remember, what am I saying? I'm gonna add this piece because I want to me it's innately obvious, but I'm not sure based on some of the things I saw in the test. When I'm saying to get it on the left, I'm saying of the equal sign. When I say on the right, of the equal sign. Then you're going to multiply or divide both sides, bless you, my goodness, sneezy from, by the coefficient of the variable. Now you're just being silly. Okay, so that's just the basic premise behind what we do when we solve equations. What's going to be strange is that we're not going to see a lot of constants, and we're not going to see just one kind of variable. That's going to be the weird thing. So we've got 3 examples. And again, this is when I'm, let's see, we're going to solve for named variable. So there's going to be more than one variable, and they're going to tell you which one they want you to solve for. So we've got 4m minus 3n equals 8. And so this is very simple, and we want to solve this for m. So basically what this says is let's get m all by itself. So what's happening to the m?
Multiply.
It's being multiplied by 4. What else? 3n is being subtracted from it. Okay, according to our order of what we need to do, what's the first thing I'm going to have to do to the m? Divide by 4 or deal with the minus 3n? Yeah, notice we add or subtract first. That's our first job. So we're going to get rid of the 3n, and the inverse of subtracting it would be adding it. Now, can I add 3n to 8? No, they're not like terms. So what I'm left with is 4, and I still have the m, equals, and it doesn't matter if you write 3n plus 8 or 8 plus 3n. I'm just so used to always putting my variable in the front and my constant in the back. That's what you're going to see me do every single time. Okay. Now what do I need to do to get the m alone? Say it again? Divide by 4. But when I divide by 4, I treat everyone the same. I've got 3 terms. All 3 of them are going to be divided by that 4. So 4 divided by 4 leaves me with my m, which is what we were told to solve for. And then I cannot divide 3 by 4, so I get left with 3/4 n. So just a comment about that. When you have a coefficient that's a fraction, the variable has 2 choices where it can be. It can be like what I've done, opposite the fraction bar, or it needs to be up in the numerator. If it's in the denominator, you will get marked down for that. Okay? And then we have a plus, and then what's 8 divided by 4 is 2. And that's it. So what's very different about these equations is that we're not getting an answer, so to speak. We're not getting what the variable m equals as a number. We just get an equation where m is by itself. And the reason why we do this is, what if I told you what the value of n was? Then you could solve very quickly for m if you had solved the equation for m. Okay? So that's kind of what people do. All right, we're going to get a little bit more complicated. Everybody ready for me to move here? Yeah? Second one, we've got 3x minus 2y equals xz, and I want, plus 5, and I want you to solve this for x. So here's the complication. X doesn't show up once. X shows up twice. Okay? So what do you think we can do to solve this one? Brandon?
Is the both x's on the same side and combine like terms?
We're going to try the best we can, but for sure we have to start with that. We need to get the x's on the same side. Okay? So what can I do to get the x's on the same side? I can't just add an x to 3x, because it isn't just an x. Lainey? Okay, you could do that. That's gonna have to happen eventually, right? So we can do that now. Bottom line is, I only want x terms on the other side, so I am going to have to get rid of this y term. We could do that now. Okay, but Brandon was talking about, hey, we need to get all the x's together. Actually, let me start with him being red. It'll be easier. So we have 3x equals xz plus 2y plus 5. Okay, now what do I do? How do I get the x terms together? Philip? Nope, you need to come up. Well, you guys have homework tonight on this, so stretching's not going to get the answer for you. Michael? Nope, can't do that. Alicia.
Wouldn't you take the xz and subtract it?
Very good. Remember, we're in adding and subtracting at this point. That's our only option. Now, can I combine, are 3x and xz considered like terms? No, they are not. So, I still have two different terms. Okay. Now, how do I get something that shows up twice to only show up once? We did this back in chapter 1. Okay, Patrick, what do you think?
Combine them?
We can't. And the reason why I can't combine them is they don't have the same variables. They don't both have x and z. So I'm kind of stuck with, I can't mush them together. What can I do? Lainey, you remember? I give you a hint. It is the distributive property, but it's one of the three options for distributive property. The most common thing we think about is removing parentheses. This is not what we're doing on this particular problem. There's no parentheses to remove. But there are two more things that I can do with the distributive property. What do you notice that both those terms on the left have in common? Pardon me? They have an x. So we had talked about in chapter 1 that when we have a variable in common, we can factor it out. And we factor it to the back end. Okay? We could factor it to the front end, but to me it just makes more sense to have it in the back end. So what's 3x divided by x? Just a 3, right? And then we have a minus. What's xz divided by an x? Say again? What's xz divided by x? Z. So I have the quantity, 3 minus z, that times x, equals 2y plus 5. So the question is, what's now happening to the x? What math is going on with the x? Multiplication. So what's the inverse of multiplying by the quantity 3 minus z? Dividing by the quantity 3 minus z. So I get the x I wanted to get alone. In the top, the numerator is the 2y plus 5. In the denominator is 3 minus z. Could I have parentheses around what's in the denominator? I could. It's not necessary because there's nothing to multiply to get rid of the parentheses, so I don't need it. Now, one thing we do need to talk about with this particular problem is, do we have any limitations as to what our answer could look like? So with limitations, or you'll hear the word exclusions. We sometimes need to exclude things. You're going to look at the denominator. And what's the one thing we said a denominator can never equal? Denominator. Yeah. So a denominator can't equal 0. So is there a value for z that would make the denominator 0?
0. 3.
3. So what we're going to have to think about is if z equals 3, the denominator equals 0. So z equals 3, z can't equal 3, and we'll put it that way. So that's the one number in this whole entire problem we cannot have for z. He can't equal 3, because if he equaled 3, he would make a 0 in the denominator, and we can't divide by 0. Okay? So you need to look for potential exclusions from answers. And the only thing you're looking for is what makes your denominator equal to 0. So if we get something that makes your denominator 0, we have to eliminate it as an answer choice. So let me give you another example, and we'll just look at that piece of it. So let's say that you did your work, and this is the answer you got. Let's see, Q equals 18 plus T equals 6 minus R. So what number do we need to exclude as being a potential answer because it would create that 0 in the denominator? Jackie? And what variable can't equal 6? So our exclusion would be R cannot equal 6. Every other number would be fine, but specifically I cannot let R equal 6. T could equal 6. That would be fine. That's not a problem. It's just specifically in the denominator that I need to look for numbers that would create a 0 down there and have to eliminate it. All right, so the last one I want to talk about is a formula problem. So in formulas, what happens, let's say that we're talking about, this is kind of strange. The largest yo-yo in the world is 32.7 feet in circumference. Okay? They launched it from a crane at a height of 189 feet. Okay, I'm not making this up. Okay, it's Guinness World Book of Records. Says no jive, 3-to-1 yo-yo. Okay, or 3-in-1 yo-yo. So this massive, okay, 32.7 feet. That's massive. Massive yo-yo. Circumference. Okay, circumference all around the outer edges, right? Oh my word. But our curiosity is, well, what would the radius of that circle look like? So we have a circumference formula. Let's do it this one. Circumference equals 2 pi r. Okay? But what we want to do is to figure out what does the radius equal. So we can do the same thing. We can transform this literal equation to have it solved for r, and then substitute in what we know. So we're going to take the c equals 2 pi r, and I want to keep the r. So what math is, oh, it'll come back in a second. Okay. What math is happening to the r?
Multiplication.
It's being multiplied. What's it being multiplied by?
2 and pi.
2 and pi. So what I'm going to do is the inverse. I'm going to divide by the 2 and the pi. And I get the variable I need, r, is equal to c divided by 2 pi. So in this particular problem, to figure out what the radius would be, I'll just write this out. So we're going to put in, since they told us that it's 32.5 feet, or actually it's still in equals. We had a 32.7 foot circumference, and we want to divide it by 2 pi. And pi we use as approximately 2.14. We can use 22/7, whatever we need to use for the calculation. Most of the time we use 3.14. In the high school they tend to use a calculator, which would give you more digits, 3.14159 or so on and so forth. The answer comes roughly out to 5.2. So think about that would be like me laying down on the ground, and that's half across this yo-yo. So take me twice, and that's across the yo-yo. That's pretty insane. So that's what we do, is sometimes solving a formula for different variables what we're going to need, and that's going to show up when we're doing motion problems in next week. Yes? Pardon me? It says 29 and 31. Yeah, 29. Yeah, what you're seeing is the comma from after odd. Yeah. All right, good luck.